Hello, Mr. Mailer here, your online math teacher, and welcome to my channel. Today we're going to be continuing my video series on trigonometry. In particular, we're going to be going back to solving trig equations, but unlike before, we're going to be doing them with trigonometric identities now. So these are more complicated examples of what I've done in previous videos. So if you find this video helpful, consider hitting the like button and subscribing, and let's go. So there's really a couple of different types of identities your teachers will probably need you to use in them, whether they be Pythagorean identities, double angle, addition subtraction formula. And usually based on the given information, your goal is going to be just like any other equation you want to solve. Get everything to one side of the equation and then try to break it up into factors and set those factors equal to 0. So that's the same goal now. To accomplish that in this problem, I'm going to start by moving over my 2 cosine of x to the left-hand side of the equality. Once I have done this, I need to get it to something that factors. Well, I don't have anything that looks obvious now, but what might help is if I write everything in terms of just one trig function. So if I can write everything in terms of sine or cosine, that might be a good way to go. Now, I don't have a reasonable identity to use to write sine in terms of cosine. I would need to mess with what's inside of the trig function to do that, which I don't want to go there. But we have Pythagorean identities, which are going to let me rewrite cosine squared of x in terms of sine. So I'm going to do exactly that. Now that I've done this, I'm going to distribute and simplify to see what I get, and that will leave me with the following. And now this kind of looks like a quadratic. So it's not uncommon that you'll get these problems from your teacher. It'll look like something squared plus something plus something. So it kind of looks like a quadratic. If I were to replace sine with a, this would be 2a squared plus 3a plus 1 is equal to 0. And you're used to factoring quadratics. The only difference is you have signs here. So we're going to factor just like it's quadratic. So to get ourselves, and now that I'm here, I can set both of these factors equal to 0. So I have 2 sine of x plus 1 equal to 0 and sine of x plus 1 equal to 0. And I can solve each of these equations to recognize that they're both going to yield nice values that I know the y coordinates for on the unit circle. Because remember, on the unit circle, sine looks like the y coordinate. So by drawing myself a unit circle and drawing lines for y is equal to -1/2 and -1, I see I'm going to have 3 solutions within one full trip around my unit circle. So for my equation sine of x equal to -1/2, I'm going to have 2 solutions here. So I get 2 solutions between 0 and 2 pi. And then for my equation y is equal to -1, I pick up a third solution, which is 3 pi over 2. And these are just ones I chose. All we need is to pick one specific angle that's going to put us at each of those locations. Because then I just might use these to write my general equations for my solutions here. So to do that, I'm going to get 2 equations out of my sine of x equal to -1/2, which are the following. And I'm going to get a third equation from solving sine of x equal to -1. So as you can see here, I get my 3 equations, and I let n be any integer in these, and it'll give me all possible solutions. And any of your equations here might look slightly different if you picked a coterminal angle to either -π/6, 7π/6, or 3π/2. So just swap out that coterminal angle for what I wrote in each of those spots, and those equations would be good also. So this is an example where I used a Pythagorean identity to be able to solve a trigonometric equation. I'm not always just going to use Pythagorean identities though. I might use other identities, and I might want just the solutions between 0 and 2 pi. That's also a common thing. Now, in this equation here, the second you see a cosine of 2x or that 2x inside, that should make you think, oh, is there a double angle identity I can use? And if you don't know the double angle identities, you could try using your addition and subtraction formulas, and you could get there eventually, but it's a little bit more complicated. So I recognize that, hey, if I want to solve this, and sorry, I was supposed to write that that's equal to 0 there. If I want to solve this equation here, I want to be able to factor it. And I remember that there is 3 double angle identities for cosine of 2x. And these are my 3 different double angle identities for cosine of 2x. And I could say to myself, well, which one of them looks like it might be most useful? Well, typically, writing everything in terms of the same trig function might be handy. So the first and third ones I have listed here maybe aren't as good. So we'll try that middle double angle identity. So we're going to replace cosine of 2x with 2 cosine squared x minus 1 to give us the following. And if I rearrange it, I'm going to see pretty nicely that this looks like one of our quadratics again. So I can factor this, in fact, so this is the quadratic that I get. Now it's the same game as what we did in the last problem. You can set each of these factors equal to 0 to then solve. And again, I know these are nice values on the outside of the unit circle. And since cosine is the x coordinates on the unit circle, I can draw a nice picture to be able to look for which x values are going to correspond to 1/2 and which are going to correspond to -1 on my circle. So I draw my picture. So I have this picture, and since I'm looking for my 3 angles here that are going to be between 0 and 2 pi, I see that my x equal to -1/2 is going to give me 2 angles for solutions, and those angles being pi over 3 and 5 pi over 3. So those are my 2 angles that are going to put us here. And I want them between 0 and 2 pi. So that's why I've picked these 2. And then my third angle, which I pick up from my equation cosine of x equal to -1, is just going to be located at pi. So my third solution is pi. And since I only wanted the solutions between 0 and 2 pi, this is my entire answer. I'm not going to generalize it with a formula. So here were 2 examples of how you can use identities to solve trigonometric equations. I hope you found this video helpful. If you did, hit the like button and have an awesome day.